All right, this is a reminder, everyone. Please make sure that you are opening up your notes. Remember that you can get normal credit for notes for doing notes whenever, but if you want attendance credit, you do need to do your notes actually during class. Remember, try both links. One will work, one won't. Otherwise, it's all over your course page. Just go to your grades tab, your content tab, your plan tab, or your announcements. It's literally everywhere. All right, so again, remember that if you do notes at any time, that'll give you notes credit. If you do notes during class and pass, that gives you notes credit, and attendance credit. Okay, you do not get attendance just for logging in. You do only get attendance if you do your notes and pass them during class. Go ahead, give me a smiley face or an emoji in the chat box, everyone, if that makes sense. Let's go ahead and go over some of these answers up on the board. So let me take a look here. So independent variable, yes, this is the thing that you have the ability to choose. The word independent is like when you're old enough to make your own choices. So the independent variable is what you choose to change on purpose at the start of an experiment, absolutely. Your dependent variable, on the other hand, is what's dependent on the results, right? So the dependent variable is the result that we measure at the end of the experiment. And then finally right here, constants, like the word sounds, stay constant. So they are everything else that needs to stay the same in an experiment. Remember that we can only change an independent variable, one independent variable at a time. Otherwise, we don't know what's causing our dependent variable effects. We don't understand what's causing our final result. So we only change one independent variable at a time. Everything else needs to stay constant. Excellent job on that, everyone. Okay, perfect. Thank you. All right. So again, please make sure that your notes are open and ready to go. So here is the links in the chat box. And again, you can start raising your hands right now. Again, if you want attendance, you have to do the notes during class and pass them during class. That's literally all I check when I check for attendance, is that you did your notes during class and you pass them. I don't give attendance words or anything like that, only that you're doing your notes during class. Perfect. All right, everyone, let's go ahead and talk a little bit about this. This is a reminder, please do not share contact info. Please make sure you are participating often and well, and make sure that you are behaving appropriately. And don't forget that these sessions are being recorded. We are on day 6 out of 60, officially 10% of the way through the trimester. Don't forget, so today we will be taking a look at experimental design and completing the 1E notes. Please don't forget that if you are a new student, meaning that you can see your name here in this list, that you are required to do STAR 360 math and reading assessments at both the start and end of the trimester. Remember, these are like school-wide assessments where we test how you are doing in your math and reading classes to make sure that you are improving in those skills, because those are some of the most crucial skills to be successful in all of your classes. So if you're a new student for Try 3, though, you're in this blue box. You do need to do them both at the start and end. So you should have done reading yesterday at 1 p.m. and you will have math today at 1 p.m. Please try to make sure that you go to those sessions. Otherwise, the STAR 360 team will come and hunt you down, which it's more fun to just do it now as opposed to having to be hassled by the STAR 360 team. Okay. Everybody, including new and old students, will then need to do it at the end of the trimester. So old students, you do it once at the end of trimester. New students, you do it twice, start and end. Please do not do STAR 360 before the end of the trimester, old students, because it will not count towards your STAR 360 grades. You need to do it during the time frame that we specify so that we're getting good data on your reading and math skills. Okay? All right, so taking a look at experimental design today, we're going to be able to define and identify what a control group is versus an experimental group. And we will also be able to define what is quantitative versus qualitative data. And again, we will be working on the 1E notes today, so make sure you have those open. Links are in the chat. I have 6 people with their hands raised already, waiting on the remainder of you, so 20 more seconds to open up your notes. And make sure that you start it and acknowledge the attendance policy, that you have to be here and that you have to actually do your notes during class to get attendance. What I want to know, in an experiment, why don't we change several things at once? Go ahead and tell me in the chat. We actually kind of just talked about this, but let's imagine that I have a dart-shaped airplane made from newspaper with a paper clip on its nose, and I have a glider-shaped airplane made from computer paper with no paper clip. Why would this experiment not make sense? Go ahead and tell me in the chat box. Why does this not make sense in an experiment? If I want to figure out what's going on in an experiment, why wouldn't I change 3 things at the same time? Yeah, you should only change 1 thing at a time, right? Because if we change 3 things at a time, then I don't know why my plane is being successful. I don't know, is it because it's dart-shaped? Is it because it's made out of newspaper? Or is it because of the paperclip? Same thing down here. I wouldn't know if it's because of the glider shape, the fact that it's made out of computer paper, or the fact that it has no paperclip. There are too many variables going on that I don't know what's causing one plane to be better than the other. Yeah, smiley faces in the chat box if that makes sense, right? So if there are too many variables changing, we don't know exactly which one is causing an airplane to be better. Perfect. That's why, for example, in our project, in our airplane project, I specify that each of your airplanes has to be made out of the same paper. All right, so if it's made out of computer paper, all 3 have to be made out of computer paper. If you're making it out of construction paper, all 3 have to be made out of construction paper, because otherwise your result might change based on the paper instead of the actual shape of the airplane. And our experiment in our Unit 1 project is based on the shape of the airplane, not the paper of the airplane. Okay, so this is why we don't change several things at once. We try to only change 1 thing at a time, our independent variable. Excellent. So that's kind of a brainstorm from yesterday, as well as bringing it together with talking about our project. Now let's go ahead and talk a little bit more about this. So again, the independent variable is what we are changing, right? So we learned yesterday that our independent variable is what we change on purpose. It's what we're testing in our experiment, okay? However, in an experiment, we often have different groups, right? Because we're trying to test things based on as we change our independent variable, we're trying to test different groups, right? We want more data than just one group. We want a range of groups, okay? So here we go. In an experiment, we will often have a control group, and we will also have either 1 or more experimental groups. Now, the difference between a control and experimental group is what's happening with the independent variable. So in the control group, either the independent variable is kept at 0, or it's kept at whatever is considered normal. Smiley faces or emojis in the chat box if that's beginning to make sense. Again, our control group, the group we're controlling for, is either kept at 0 or normal. Perfect. Yes. Awesome. All right. Now, what we use the control group for is we use the control group to make comparisons. So, for example, if you think about like medical trials, especially with like the vaccine trials right now, there are people that either get the vaccine or there are people that get a placebo. Placebo means that they're not getting the vaccine, that their independent variable is staying at 0. They get 0 of the vaccine. And the reason we do that is because we have to be able to compare what's happening with our experiment versus what's happening if things are kept normal. So a group that does not get a vaccine versus a group that does get a vaccine. Otherwise, our data doesn't really mean anything, right? You can say, oh, these people didn't get sick and these people got sick, but unless you have a group to compare it to, you don't know if it's doing any better or not. You don't know if the vaccine is actually helping or not, right? So that's why we need a control group in most experiments, okay? Now, the experimental group, on the other hand, is where we do begin to change our independent variable, right? So this would be a group that does actually get a vaccine. Now, there can often be more than one experimental group. So, for example, during some of these COVID vaccine trials, there were some groups that got different doses or amounts of the vaccine because they were trying to figure out what is the safe amount of vaccine as well as what is going to be the most effective dose of vaccine, right? Because they don't want to waste it and they also don't want to hurt people. right? So by having different groups with different amounts of vaccine, that helps you figure out which amount is going to be the most effective. Okay, this is also true with other experiments. Again, experimental groups are where we actually change the independent variable. And now we get to see what happens when that independent variable is is actually a factor, if it's actually is in play. Okay, now in all of these groups, whether or not you're a control group or an experimental group, remember that everything else needs to be identical and the same. So these are the constants, these variables that need to be kept the same in all groups. So for example, in the vaccine trials, control groups and experimental groups had similar ages. They had similar makeups in terms of like people's health, people's gender, right? So just based on, they tried to average everything out and they try to control for all of those other factors that could somehow make a difference, right? Because if your control group is a bunch of healthy 20-year-olds, and your experimental group is a bunch of 70-year-olds, all right, again, the results in a vaccine trial wouldn't make sense because you wouldn't know if it's because of their age or because of the actual vaccine that's making a difference. Go ahead and give me a green check or an orange X if that's beginning to make sense. Control group, our standard group, experimental groups where you actually start to change the independent variable. All right, this is going to be the answer to number 2 and number 3. I see some of you have already answered it and raised your hands, but let's get everyone else. 30 seconds to fill in the blank for number 2 with 0, and 30 seconds to fill in the blank for number 3 with the word changed. Make sure you only put what you see in red. Make sure you spell it correctly, otherwise the computer will mark it as wrong. 20 seconds, raise your hands. Okay, so let's go ahead and try this out. Let's go ahead and do the first one together. So this is the same experiment as yesterday. Yesterday we identified the independent variable, the dependent variable, and the constants. Today we're going to figure out what's going on with the actual groups. So we have 5 groups of potted basil that are watered different amounts each day. 200 milliliters, 150 milliliters, 100 milliliters, 50 milliliters, and no water. The number of leaves are counted at the end of the month. So I want to know in the chat box for now, eventually you will need to use the board tools, but for now, tell me which of these is the control group, okay? Which group is considered the control group where our independent variables either at 0, normal, or baseline? Again, thinking about the COVID vaccine trials, right, where they have a group that gets a placebo, one without the vaccine. Okay, go ahead and tell me in the chat box, 200, 150, 150, or no water, which of those would be the control group? The group where our independent variable is at 0, normal, or baseline. Yeah, perfect. The one with no water. Absolutely. So this would be, for example, a control group. All right, so let me go ahead and box this right here. All right, so where there's no water, right, there's no independent variable involved, right? We already said earlier that our independent variable is the amount of water, right? The amount of water is our independent variable. And so the group with no water, no independent variable, should be the control group. Smiley faces or emojis in the chat box if that makes sense. Smiley faces, emojis in the chat box if that makes sense. Okay, so now the experimental group, or groups, is where our independent variable changes. So this, in this case, would be what group? Tell me in the chat box. What group or groups have the independent variable, the amount of water, changing? Yeah, so Erica, that's definitely one of them, the group with 50 milliliters of water. What else? What other groups are we changing the amount of water, where it's no longer at 0? Awesome, I see Jonathan, I see Callie. Yeah, the group with 100. The group with 200, what else? What groups do you have the water changing? Tell me in the chat, what groups is our independent variable changing? Thank you, Lena. Yeah, so all of our other groups, okay, all of these count as experimental groups because our independent variable has changed, right? It went from no water, 0, our normal, to 50 milliliters, 100, 150, and 200. Go ahead and give me a green check, orange X if you're beginning to feel comfortable with that. You do need to participate on the board in the next step, in the next check. So here we go. Get ready for that. Perfect. All right. So you have your whiteboard tools. A student wants to find out which kind of fish food is the most nutritious. There are 4 groups of fish that get different foods: regular flakes, pellets, freeze-dried shrimp, and bloodworms. Their weight is measured daily. So which of these would make the most sense as the control group? The one with regular flakes, pellets, shrimp, or bloodworms. Again, control group should be 0 or normal. The group that has 0 independent variable or a normal independent variable. Excellent. I see Tim on the board. I see Seraphim. I see Callie up on the board. There we go. Perfect. Yeah, absolutely. So let me go ahead and pause this right here. All right, I'm going to go ahead and clear this out. So yes, the group with the regular flakes would make the most sense as our control group, right? Because that one is the one that is the most normal. All right, we can't just not feed the fish because the fish will die. So in some experiments, you can't just give them nothing, right? So in this case, you have to make sure that you actually give them something. So in this case, the regular flakes would make the most sense as the control group. So then go ahead and think about which group or groups would therefore be the experimental groups. Go ahead and circle those up on the board. Again, there's probably going to be more than one. Experimental groups is where we change the independent variable, the one where we change the food. Okay, so our food again was our independent variable. Go ahead and get your answers up on the board. Think about up here, we had our control group. Every other group was the experimental group. Right, so think about what would that look like down here. Go, 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 get your answers up on the board. Excellent, I see Jayland up on the board first. Let's get some more answers up there. What would make sense to be the experimental groups? Thank you, Cody. Perfect, getting some more answers up there. Awesome. Sorry, whose is this one? Matthew, I see you up there. Get some more answers, everyone. Perfect, Lexi. Excellent, Seraphim. Yeah, let me go ahead and pause those tools. Yeah, basically everything else. So every other group would be the experimental group because we're changing the independent variable from its normal, right? So pellets, shrimp, and bloodworms would all probably be different types of foods than normal, and so those are all experimental groups. Excellent. All right, so this is going to help us with number 4 and number 5. For both of these, it explains what the control group is. So the control group for number 4 is the group with no water. The control group for number 5 is the group with regular flakes, where the independent variable is either at 0 or at normal. It depends on the experiment. You have 30 seconds to fill in number 4 and number 5. They're multiple choice. Raise your hands. They should be fast. Go, go, go. Number 4 and number 5. Number 6 is one that you need to complete on your own. So 4 groups of corn are given different types of natural fertilizer: fish emulsion, worm castings, cow manure compost, and no fertilizer. The height of the corn is measured each week. All right, so the question here is, what is the control group? Don't put answers in the main chat. But when you think about control group, this is where the independent variable, which in this case we learned yesterday was the fertilizer, is kept at 0, normal, or baseline, depending on what type of experiment it is. Okay, so based on this, what would make the most sense as your control group? Go ahead and answer number 6. If you want to check your answer, I'm in the Q&A chat. Please don't put answers in the room chat, though. You have 30 seconds to try to answer number 6. Go, go, go. Let's go ahead and talk a little bit about the data that we collect, because tomorrow we'll be talking about graphing. So today I want to make sure we get a chance to touch on talking about data. So when we get our data, our results from our experiment, organizing the data is very, very useful. Otherwise, you just end up with a bunch of measurements, and the measurements don't really mean anything. So by organizing the data, you can better understand the results. Generally, but not always, but generally, we put the independent variable, what we change on purpose, the cause of the experiment, the start of the experiment, on the left side. So for example, you can see here water depth, right, is what the scientist is starting with. And then the dependent variable, what you end with, what you're measuring, the final result or effect, generally gets placed on the right side. So in this case, the result that he's trying to figure out is the temperature at each of those water depths. That's his result that he's measuring. So he puts that on the right. Now again, organizing this is helpful because what you can notice is the deeper that you go, what happens to our temperature? Tell me in the chat box, what pattern do you notice happening? As we get lower and lower and lower and lower, what's happening to the temperatures? Deeper into the water, what's happening to the temperatures? Awesome. I see Jonathan making observations in the chat. Take a look. As we get lower into the water, what happens to our temperatures? Let's get some more answers. I do see Jonathan. Again, the more you participate, the more you learn. Otherwise, Jonathan's the only one learning, and that's good for Jonathan, but not for you. Yeah, exactly. It's getting colder and colder and colder. Thank you, Lexi. Thank you, Cody. Yeah, we start off with when we're in a pretty shallow area, right, at 50 meters, we can see that it's much warmer. It's 18 degrees Celsius, which I don't remember what that is in Fahrenheit. Let me see. 18 degrees Celsius in Fahrenheit would be 64 degrees Fahrenheit. All right, so cold, but not freezing. Whereas you get lower and lower and lower, right? So this one is much lower. And we suddenly get colder and colder and colder, down to 4 degrees Celsius. 4 degrees Celsius, which is about 39 degrees Fahrenheit. Okay, so it gets colder. So this is why we want to organize our data. It helps us to make sense of what's happening and if there is in fact a pattern, because that pattern will be helpful for determining the results of our experiment. Okay, now there are two different types of data that you can get. A lot of times in experiments we want to get quantitative data because quantitative data is something that is very measurable, right? So this is based on measurements, otherwise known as numeric data. Data that has to do with numbers. So for example, if you take a look here, I could ask how many chocolate chips are on a cookie. If I have 20 cookies and I'm trying to figure out some data from the cookies and try to figure out how many chocolate chips on average are in a cookie, I would count up the chocolate chips in each cookie. So this one right here, for example, seems to have like 6, 7, or 8. Right? And then I would count up the other ones. Anytime I get numbers, that is quantitative data. You can see the root here, right here, is the word quantity. So quantity means amounts, means measurements, means numbers. Go ahead, give me a smiley face or an emoji in the chat, or a yes if that's beginning to make sense. Again, quantitative means numbers, 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 numbers. Thank you, Lexi. Thank you, Lena, Itati. Awesome. Thank you, Joseph W. Perfect. Now, qualitative, on the other hand, means it's based on qualities, and qualities are not numerical. Okay, they are not expressed by numbers, and this is still useful data. So for example, in an experiment, we do again try to get measurements as much as possible, but you might also have things like colors, and colors can't necessarily be described exactly by a number, unless of course it's like on a computer, but in real life it's hard to describe a color with just a number. So instead what we can do is we can describe it in an experiment and say, oh, it's kind of a blue-green color, or it's a purple-red color, you know? So that is a type of quality or qualitative data. So an example down here is if you're saying the sloth's fur, is it smooth and full, or is it rough and patchy? Those are descriptors, they're not numbers. So any type of data that I would provide that's not numerical is qualitative. These are the answers to both number 7 and number 8. Please raise your hands when you have these filled in. Again, capitalization does not matter, but make sure you spell them correctly and only put in what you see in the red boxes. Otherwise, the computer will mark it as wrong. You have 30 seconds to answer both of those and raise your hands. I already see 10 of you with your hands up. Y'all are on top of it. 25 seconds for everyone else. Okay, so I'm going to go ahead and give you whiteboard tools, and I want you to begin thinking about, are these quantitative or qualitative properties? Again, quantitative, you should think of the word quantity, like a number. Qualitative, you should think of qualities, like characteristics. Qualities, okay? So let's go ahead and take a look here. Are all dogs black and white, right? Tell me, would that data be quantitative, numerical, or qualitative? How many people can fit in a car? Is that a number, quantitative, or qualities, qualitative? How much does the new baby weigh? Is that quantitative or qualitative data? And finally, does that donut taste nasty or sweet? Quantitative or qualitative? Go ahead and circle those answers up on the board. I see Lexi, Callie working. Awesome. Let's get some more answers. I see Erica up there. I see Lena working hard. Perfect. Get your answers. Thank you, Seraphim. Beautiful. Get your answers up on the board, everyone. Shayna, awesome. Alexander, I see you. Looking good. All right, there's so many people, it's hard for me to click now, so I'm just going to go ahead and keep on moving. Perfect. All right, let me go ahead and pause these tools. This looks amazing. You are correct. Black and white, those are colors. Colors definitely mean a quality, right? So that's going to be a descriptor, a characteristic, a quality. It's not number data. How many people can fit in a car? Anytime we talk about how many, right, that's definitely talking about an actual number. You wouldn't say a color to describe how many people can fit in the car. You would give me an actual number. Same thing with baby weight, right? Anytime we talk about weight, weight is a measurement, so that's quantitative or numerical. And does that donut taste nasty or sweet? Again, that's not something we can really quantitatively describe, right? Someone tasting a donut would not say, this is a number 3. Instead, they would just say, oh, it tastes good, or it doesn't taste good, or it tastes really good. So that would be a qualitative type of data. Go ahead and give me a smiley, medium, or sad face based on how you feel about this. You will need to be able to do the next one on your own. Excellent. All right, let's go ahead and try the next one. So this one is a complete on your own, but you can check your answers in the Q&A area with me. So you need to figure out, are these things quantitative, numerical, numbers, or qualitative? Remember, characteristics, right? Oops, sorry. So qualitative means more like characteristics. Characteristics, okay? So the age of a person, the smell of a substance, the color of someone's eyes, and the height of a tree. Think about if it's related to numbers, you should be able to call it quantitative. If it's not related to numbers, that would be qualitative. Please go ahead and work on number 9 and raise your hand when you're ready to move on. You have 40 seconds to work on that. If you're uncertain about any of them, just check in the Q&A box with tell me what you think it is, and I'll tell you whether or not you're on the right track. Go, 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 raise your hands. Taking a look here today, we talked about control groups versus experimental groups. Control groups where we keep everything at 0 or normal. Experimental groups where we begin to actually change our independent variable. And we talked about quantitative numerical data versus qualitative characteristic data. All right, so go ahead and point for me up on the board using your colored arrows. How do you feel about these things so far? Talking about control versus experimental groups, talking about quantitative versus qualitative data. Awesome, I see some purple, reds, and pinks up on the board. Go ahead, point for me, where are you at? The arrows are anonymous, so be honest. No one else can know whose arrow is who. Awesome, I see some yellow, some green. Perfect. Looking good. All right, looks like a lot of us are in the good or even the awesome range. That's what I love to see. If you do feel like you need help, though, please make sure you're coming to office hours. I have office hours on Thursday in the afternoon. You should already see them on your Class Connect page, okay? Make sure that you submit your 1E notes. Let me know in the chat if you got an A or a B. I want to shout you out. And let us know if you did great on that. Hope you did. Remember, make sure you submit that right now. That way I can also give you your attendance. Thank you so much, everyone. I will see you later.